Hello, the objective of this video is to learn how to graph linear equations using the y-intercept and the slope. By now, hopefully you've become familiar with this form of equations, which is the slope-intercept form of equations, where m is the slope of the line and b is the y-intercept. Hopefully you're also familiar with the fact that the slope is equal to the rise over the run. We're going to be working with that in order to graph equations. So let's start off with an equation. Let's say we have y equals 2x plus 4. Now by now, hopefully, we've learned that you can set up a table of values, choosing your own input values, plugging them into the equation. Negative 2 times 2 is negative 4, plus 4 gives me 0. To get your y value, plug in 0, 2 times 0 is 0, plus 4 gives me 4. 2 times 2 is 4, plus 4 gives me 8. Right? From there, I would go to my graph, and I'd plot these points. Remember, to plot points, you've got to run before you can jump. So you've got to go over the negative 2, and then up 0 would be this point right here. 0, 4 would be 0 for the x, up 4 for the y. 2, 8 would be over 2, and up 1, 2, 3, 4, 5, 6, 7, 8. So I've got 3 points. Once I've got the 3 points, 2 is really a minimum, but once you've got 3, you've got that, draw the line through them, put the arrowheads on the end, and you've got your graph. Well, wouldn't it be nicer if we didn't have to do all that plugging and chugging? There actually is a way. Just by looking at that equation, y equals 2x plus 4, we know the y-intercept should be at 4. So right away we can get that point. So just by looking at the equation, we can find one point that we know is on the line. Then we also can find the slope. And the slope is rise over run. So that means that's 2. Well, rise over run, well, 2, in order to make that into a fraction, I have to put it over 1. So the rise is 2, and the run is 1. So for every 2 I go up, I'm going to go over 1. Rise up 2, 1, 2, over 1, that gives me a point there. That wasn't one of my original points. However, if I go up 2 more and over 1, I hit a point that I had found. Well, how am I going to get down to this point? If I'm using rise and run, how do I go this way? Well, so far we went up 2 and to the right 1. Going up is positive. Going to the right is also positive, because that's where the positive number is on the negative on the number line. However, going down is negative, and going to the left is negative. So if I want to keep my slope at a positive 2 over 1, I've got to keep the whole fraction positive. Negative 2 over negative 1 is positive 2. It's the same thing. So if I'm going to go to the left, though, that's going to be going down 2 to the left 1 would be negative 2 over negative 1, which is a positive slope altogether. And that's how I keep going in this direction. Down 2 over 1. Hit the same spot. Down 2 over 1. I can see that my line was a little off here. It should have continued down like this. Next spot here, next spot there, and so on like that. Working with the slope and y-intercept, I can graph the line pretty much by looking at the equation and moving with the slope. A lot simpler than having to draw out a table. Let's try another one. All right, let's try one where we have y equals negative 3/4 x minus 2. First off, y-intercept. This is in the mx plus b form, so the y-intercept is negative 2. which means it crosses at 1, 2, negative 2 down here. The slope is rise over run. This one says we're rising down 3. It's a negative, so we're going to go down 3. We go 1, 2, 3 down. And then we're going to run 4. That's a positive force. So we go over 1, 2, 3, 4. Down 3, over 4. Down 3 more, and over 4 more, I find another point. If I went down 3 and over 4 from there, I'd find another point. But that's going off the graph. What if I wanted to plot points in this direction? Well, I'd have to go up 3 and to the left 4. Going up 3 is a positive 3. Going to the left is a negative 4. 3 over negative 4 is the same as 3 over a negative 3 over positive 4. These are equal, the same thing. So if I go up 3 and over to the left 4, it's going to be like that. And it makes sense. It does form that straight line there. Up 3, over 4 to the left, down like this. Remember, the overall slope has to have the sign there at the beginning. So this is a negative slope. And whether I consider the 4 negative or the 3 negative, negative is going to tell me up or down. The negative is going to tell me down from the top number to the left for the bottom number. So let's try another one. Let's say we have y equals 3/5 x plus 7. So the first point we see is the plus 7, which means we count up 1, 2, 3, 4, 5, 6, 7. That's our first point. That's on the y-axis there. The next point is up 3, 1, 2, 3, and over 1, 2, 3, 4, 5. Here's a situation where I've hit the top of my graph. If I want a third point, I either have to go off the graph, which is not very accurate, or I have to go to the left. I generally like to work to the right, because right's positive, it tells me up or down very easily from there. But if I'm going to go to the left, that means I'm going to have to go down 3 to make it negative, and over 5 to make it negative. Negative over negative, negative 3 over negative 5 is the same as positive 3/5. Down 3 over 5 more, I get another dot. You only need 2 to form a line. It's best to have 3 so that your accuracy is better there. Why do I go to the 4th dot there? It helps me make sure that when I'm hand drawing a line like this, without a ruler, it helps me make sure that I am continuing in the right direction and they're not wavering off like I did a little here. Let's try another one. Let's say you have y equals 5/2 x plus 2. Plus 2. Right away, I can tell it's crossing at positive 2, which is not here, it's up 1, 2. It's crossing right here because that's the y-intercept. The slope is 5 over 2, so I got to rise 1, 2, 3, 4, 5, and I have to go over 1, 2. Notice how I'm going from the point here. This is not the same thing as the graphing a single point. From graphing a single point, I have to go from the origin each time. If I'm graphing the line, I'm going from the point I started at, and I got to count up and over or down and over from the y-intercept. So I went up 5 over 2. Up 5, I'm going to go off the graph, which means I better go down 5 and to the left 2. Negative 5, negative 2, same direction. Negative 5, negative 2, same direction. Here we go. Here is my line for the graph. Don't forget those arrowheads. It does need to show, you do need to show that it does continue off in both directions. This equation doesn't end at that point. It continues. All right, let's put a couple of you-dos on here. I'm going to give you 2 equations. 2x minus 5, and y equals negative x plus 8. I want you to pause the video, give these two a try, and then we'll go over them. Welcome back. Let me take a moment here to erase the previous graphs here. Okay. What's the y-intercept here? It's negative 5. 1, 2, 3, 4, 5 down. That's the y-intercept. That's one point on the line. The next point we use with the slope, which is 2 over 1. We rise up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. We can keep going like that in that direction. I could also go down 2 and to the left 1, down 2 and the left 1, because I mean negative 2 over negative 1, which should still be a positive 2 slope. There is my graph for that first equation. The second equation, it crosses at positive 8. So I go up to positive 8. 1, 2, 3, 4, 5, 6, 7, 8. It crosses up here. Now here, there's no number in front of the x. But remember, when you've got x alone, it's like saying 1 times that. So we have a negative 1 slope, which is the same as negative 1 over 1. Which means from this point, we're going to go down 1 to the right 1, down 1 to the right 1. Negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. And we can keep going that direction. In the opposite direction, we'd have to go up 1 and to the left, because that would be a positive over a negative, positive over a negative. Still going to give me that negative slope. That is the graph of that line. See you in class.